Alright, so today's the first day with the sign-in sheet. All you have to do is on the first column where it's got January 20th, just you can initial in the row where your name is. You don't have to try to fit your whole name in there. Main thing on that is if you come in after the sign-in sheet's gone past, make sure you get on there before you leave. I'll try to remind you every day. So, get counted for being here. Has anybody run into any issues on WebAssign we need to talk about yet? Yes. Okay, yeah, so that's let's just look at it. That's no problem. It is useful to know, isn't it? Yeah, WebAssign doesn't give you a lot of fanfare when you're finished. So if you've used Hawks or something, at least usually they give you like a congratulations screen or something like that. Get that on WebAssign, really. Alright, so when you go to an assignment on our first one's due tonight, 11:59. As you do a problem, let's do this problem. No, not 35th. We can add. Don't pay attention to the algebra teacher not knowing how to do algebra. Worse with the touch screen. 3, not 9. Yeah. There we go. And enter. And then two ways. Okay. Once you get the little green check marks on whatever answer boxes you have, you're finished with that problem. And if you're not sure if you've got them all, you can scan down through and see if you've got them all. You can also go up to the top and like where it's got them numbered, we've got a green check mark. So we're done with number 1. And what it does is it submits every time you submit an answer. So it's like saving your work as you go. So you don't have to like submit it at the end, just when you get finished with the last one and get the green check mark, you're done. Doesn't give you a whole lot of celebration. And, always scroll along the top and make sure you got all your green check marks, or if there's one that you're decided it's not worth your trouble or something, make sure that's the only one that's got the red ticks on it. They'd score up there as you go. So one thing that came up on that one, you need to type in like exponent or fraction, something like that. When you click in the answer box, it gives you a bunch of stuff over here on the little keypad that you can use. So just in case, the one I used for the exponent is this one where you got a big box. Well, it's supposed to be a big box and then a little box up in the exponent. They look kind of. You need a square root. There's one. That's very, look how sensitive this thing is. It's like tripping out on the answer box. Okay. If you need other stuff, like there's other, come on now, going crazy. If you need other stuff, like there, we got the square root on that one. Stop it. Oh, it's because of that rag. Hang on. Keeps touching the button. I'm not sure what we hit on that. Let's see. Hang on. Technical glitches. Oh, there we go. You need other stuff that's not on that first screen. There's other things you can go through, like if you need a cube root instead of a square root. Okay. Most of the things we'll need in this class are in the first two tabs. Don't have too much crazy notation we have to use. Oh, and I don't think I've mentioned this in here either. I've got it set up where you have 10 tries on each question. 10 submissions is what they call them. But if you run out, and just hit the little, you can hit the little ask your teacher button, or there's a button somewhere that says request submissions. Somewhere in here, ask your teacher's fine. And just send me a message and I'll give you some more attempts. I've just got it set that way where if you've tried it 10 times and haven't figured it out yet, then maybe there's something I can help you with. Get that ask your teacher, but feel free, okay, when you hit the ask your teacher, it's nice for me because I can see the problem you're looking at. Sends me an email and I know to come check you're looking at that problem and help you figure out what's going on. Okay. That's it in website. Think anything else? No? Okay. So where we left off, we're doing some factoring. We did one trinomial where we needed factors of 4, add up to 5 in the middle. Our factors were 1 and 4, and then put those in, and then we had done another one where we needed factors of negative 21, add up to positive 4. Factors we found were negative 3 and 7. Factor that one. On both of these, though, the thing that was a little bit special about those last two is that our leading coefficient with the x squared term was a 1. Things a little bit easier on us. That's the because the first two terms, x and x, we just need to get 1x squared. The only way to get 1 that we're worried about is 1 and 1, so it makes these first two terms easier. Here in just a moment, we are going to look at factoring trinomials where our leading coefficient is not a 1. But before we do that, I want to look at a different factoring technique. Different technique called factoring by grouping. Factoring by grouping is not too tough. Really just an extension of factoring out the greatest common factor, the thing we started with in this section. If you can do that, you can do factoring by grouping. Let's look at a polynomial here, an algebraic expression. Got x cubed plus 2x squared plus 3x plus. So if we were trying to just factor out a greatest common factor of the whole thing, what we'd have to be looking for is we'd have to be looking for something that's in common, would divide evenly into all four terms. Right? We've got four terms with this polynomial. So maybe you could look at x, say we look, see if we have any of those in common, but we don't have an x in the last term in the 6. We don't have anything in common between 1, 2, 3, and 6. Factor out a number part. So with this idea of factoring by grouping, and what we're going to do instead of trying to find something that's in common for all four terms, we're going to group the first two terms together and group the second two terms together. And then we'll see if there's anything in common we can take out there. So what I'm saying is we're going to look at these two, and we're going to look at these two and kind of treat them separately. So if we just look at the first two terms, see anything in common? Yeah, we've got an x squared in common in that first group. X cubed and 2x squared, so we can factor out an x. If we take that out, or another way of thinking about it, it's what would we have to multiply x squared by to get x cubed x. If we factor out the x squared from 2x squared, we left with 6. So far. Now we just look at the second group. Look at that second set of parentheses. See anything in common there? Dx and 6. Thing that'll go into both of those. 3, yep, 3 is all I see as well. So we had plus out here, and then we're taking out a 3. So write that down. And then if we factor out the 3, that leaves us with an x. Leaves us with a positive 2. We've got something interesting that has happened here. Notice anything about our sets of parentheses we've got left? This thing and this thing, they match. So now the situation, you don't have to think this hard about it every time, but the situation we're in is that we have some number times another number plus some number times another number. So this thing, the stuff up to that plus sign by the 3 is one term. Got it like that. And after the plus sign in front of the 3, we've got another term. So we've got a product plus another product. In that situation, we can look for common factor. Turns out that we do have a common factor here. Our common factor is this x plus 2 thing we just. So what we can think about that we're going to factor out this common factor of x plus 2, put it in front. We factor that out, what are we left with? We're left with an x squared plus 3 That'll be times x squared. A less technical way of thinking about that. Once we get our sets of parentheses to match, then our answer when we're finished is going to be whatever's in the parentheses times the stuff that was outside the parentheses. X plus 2 times squared plus. We're finished. We're factored here. Our factored polynomial. So you just group the first two terms together, group the third and the fourth term together, treat them separately. You take out whatever's in common. When we do that, if we're in a situation where our parentheses match, then we can write our answer as the set of parentheses times what stuff that was in front of the parentheses, or we can factor out that common factor. Push. So a big hint that we might want to try factoring by grouping. So maybe we've got a problem and it doesn't tell us to use grouping, it just says factor. Big hint tell us that we might want to try factoring by grouping, that we started off with 4 terms here. 4 terms. See something with 4 terms, that's a good hint to try factoring by grouping. You can't do this just anytime you want to. I mean, if you've got 4 terms, you're not always guaranteed that when you factor out the common factor, your parentheses match. But sometimes we can. Let's do one more. Questions on that one? Always forget to ask. Factor. Group here. In WebAssign on this assignment, I think it does say factor by grouping. So that little bit. Hint. And so if we look at the first set of parentheses, anything in common? Six and the negative 5, we don't have anything, but x cubed and x squared, what can we bring out? X squared. And that leaves us with 6x 5. And it's plus. Second group, thing in common? 12x and yeah, for sure we've got a 2. 2, and I think that's the biggest one, so let's try it. 6x 5. And remember, if we're trying to factor by grouping, we're trying to make our parentheses match. So once you get this first one, that kind of gives you some guidance on what to expect on the second set. We know we need to take something out of 12x, so we end up with 6x. That can help. Then our parentheses match. And whichever way you want to think about it, we're factoring out the common factor that we have in parentheses, or it's just the stuff on the inside of the parentheses times the stuff on the outside. So 6x minus 5 times x squared plus 2 r factor. Question on that one? Sure. How many of you don't have Friday classes? Several. Oh, a bunch of you. Like your Friday day. Huh? Monday, Wednesday, Fridays are long days. Here. Okay, so that's factoring by grouping. The reason why I wanted to show you that, because when I factor trinomials that don't have a 1 leading coefficient, I use factoring by grouping. Feel free, if you are already comfortable with some other method, feel free to, you don't have to do it my way. You can do it whatever way works for you. So what am I talking about where trinomial with something that's not a 1 is a leading coefficient? Look at this. (5x squared minus 6x minus 11). These trinomials are a little bit tougher than the other ones. Here, my leading coefficient is a 5, so that's not a 1. Work a little bit harder on it. And it can be a little bit tough to teach, especially in high school. So there are a lot of different methods out there. Been taught these before. Several different ways you can go about trying to factor these, trying to think about these. So like I said, if you don't want to do it the way I'm going to show you, that's fine. I don't do it the same way I learned in high school or either. We'll talk a little bit more. So the way I'm going to do them in class is on these, we need to start off similar. We want factors of something that add up to something. We just have to treat it a little bit differently. So I'm going to start off taking first term and the last term, multiplying those together. Most of the techniques you can use to factor these start off this way. So that would give me negative 55 squared. We multiply. So now I want factors of that number. That's the number we're going to use. And I still want them to add up to the middle number. So I want factors of negative 55x squared to add up to negative 6x. That's our factors. And lots of times, since we're multiplying two numbers together, the thing we're looking for factors of is a little bit larger number. On test day and stuff, I'll try to make the numbers as small as I can. Every once in a while on WebAssign, some of the numbers are kind of randomized, so you'll get kind of a extra annoying one. It just takes a little bit longer. So what are factors of 55? I've got 1 and 55. Yeah, 2 won't go in, 3 won't go in, 4 won't go in. 5 and 11 work, and that may be all. Yeah, that's all. So this one wasn't too bad to list out all the factors. To get x squared, we're going to have an x with each one of those. Then we just, since we're trying to get a negative 55, we've got to make one of our factors negative. So we just got to figure out which one makes it come out right in the middle. Which one makes it come out to negative 6. Yeah, so positive 5, negative 11. 5x minus 11x equals negative 6x. So those are the ones we want. And that is the hardest part of these, finding those two numbers. That just takes some time. Okay, so a lot of the methods you use are really similar to this up to here. Here's maybe when things change a little bit. Now what I'm going to do is I'm going to take my two numbers I found. I'm going to rewrite the middle. Instead of writing it as negative 6x, I'm going to write it as 5x minus 11x. Then I'm going to use factoring by grouping like we did. Some of you may have never done it this way before. That's okay. Taking E factor, so it was positive 5x, negative 11x. Now I'm going to factor by grouping. Group these. So once we get here, it's just like the problems we did. We're just factoring by grouping. So in the first set of parentheses, I've got a 5x in common. That'll leave me with x plus 1. Second set of parentheses, this one may be a little tricky with the signs. We're trying to make our parentheses turn out to be x plus 1. Right now the numbers in there are negative, so we've got to switch the signs around. So I'm going to factor out a negative number to change the signs. Then the number I see in common is 11. If I take out a negative 11, that will leave me with x plus 1. You remember the step here on grouping, it's just x plus 1, 5x minus 11. It's a little messier. So we have to start off by multiplying those two terms together. And sometimes, depending on how big that number is, it takes a minute to find our two magic factors over here. Give us the right thing in the middle. But after that, it's not bad. It's just factoring. Some people use what you might call the guess and check method. So they would look at our original polynomial and say, well, I know my first terms have to be factors of 5. This one's not too bad because it's just 1 and 5 is all you have to choose from. My last terms have to be factors of 11. And when I check it, when I do the FOIL method, I've got to get negative 6 in the middle. So then what they would do is they would just say, okay, I need a 1 and a 5, I need a 1 and an 11, and then you mess around with the signs and switch in the places of the numbers until you get one that works. If you practice that a lot, you can get pretty fast at it. I'm not real good at that. It's worth it to me to just do a little bit more writing down, and then I don't have to guess. Some people do a box, make a box, and that's really doing the same thing as this. Box to have like a visual. There's a bunch of different methods you. I do not care what method you use, as long as you write down and show me what you're doing. Get the right answer. Good shape. You want to do them this way? This is the way I want to do them anytime I do one in class, but you don't have to do them. Questions on that one? We're going to do another one. Okay. Let's do another one. 7x squared minus 15x plus 2. Factor. I'm going to multiply my first and last terms together. So that would be 14x squared. Now I want to find factors of 14x squared that will add together and give me negative 15x. So 14, let's see what factors we've got. We've got 1 and 14, 2 and 7. That's it. So that one's not too bad either. And all of these will have an x. I want to figure out how we can get negative 15 out of that. This one's a little bit different. When we're done, we want a positive number. I want positive 14x squared. So there's two ways that can happen. Either both of our factors are positive, or both of our factors are negative. So we can check making both of them negative. Negative 2, negative 7, that doesn't work. That gives us negative 9. But the first row, negative 1, negative 14, that gives us what we want, right? That gives us the negative 15. Those are the ones we're looking for. Then I take those two numbers, when I rewrite my middle term. So instead of writing negative 1, I'm just going to write negative x. 14x plus 2. This is just split up into and factor by grouping. And first group, I see I've got an x in common. Leave me 7x minus 1. My second group, if I'm comparing it to my first set of parentheses, I see in my first set of parentheses I want a positive number, then a negative number. But right now I've got a negative number, then a positive number. So I know I need to switch the signs. So I'm going to factor out something negative, fix the signs for me. And the number I see I have in common is a 2. Factor out negative 2. So we'll leave us with 7x minus 1. Negative 2 times negative 1 will give us the plus 2. And we're just rewriting in the correct form. So 7x minus 1 times. Not too bad. Not like the most fun thing to do. But questions on those? If you get stuck on them, let me know. We'll do some more. One more type of factoring. And it's a special case where we just use a pattern. Our pattern we're looking for is we're looking for the situation where we have the difference squares, or the difference of two squares. You could. Okay, so what we're talking about there is we've got two perfect squares. And between those, we're subtracting. Different. So that's this situation. We've got some number squared minus some other number squared. A squared minus b. And it's always going to have the same, it's always going to look the same when we factor it. Anybody remember what it is? So we know we got to have a, to get a squared. Got to have a times a. We got to have b times b in there to get b squared. And to make the signs come out right, one of these is plus, one of these. So if we've got a situation where we've got some perfect square minus another perfect square, how that's going to factor square root of the first one plus the square root of the second times the square root of the first one. A squared minus b squared plus b. So let's look at one. Factor this one. We got x squared minus 9. X squared is a perfect square. It's got the square right there on it. So 9 is a perfect square. That's 3 squared. So factor this. Have x and x squared. To get 9, takes 3 times 3. And one of these is plus, one x plus 3 minus 2. You can check it if you want to do the FOIL method to check. So x times x is x squared. X times negative 3 is negative 3x. 3 times x is positive 3x. Positive 3 times negative 3, 9. Middle terms cancel out. Question on where any of those numbers came from? Again, don't let stuff look like magic in here. Not tracking and something looks magical, let me know and we'll go back and get you there. Look at this. So first term here, 25, that is perfect square, 5 squared. Second one may take you a little bit longer to think about, but as long as each part of the term is a perfect square, the whole thing's a perfect square. So 4, 2 squared, z squared is z squared, is the difference of 2 squares. So factor, to get 25, it takes 5 times 5. To get the 4 part, we'll have to have 2 times 2. Get the z squared part, we've got to have times z. And 1's plus 1. I write my z with a bar through it, so I didn't think what that is my z. So I do it so in the case where you're writing a 2 like that, it doesn't look. I write my 2's like this. The one I hate writing right now, the one that's giving me the most trouble, is 5. I don't write my 5s well anymore. Yes. I'm in a hurry then. That stuff you ever think about? All right. So that's that section. What was it? P6. I want us to start on. Won't finish, but I want us to start on next section. Next section we're going to work on. It's a little bit out of order from the textbook, if anybody's looking at that. Next section I want us to work on is section 1.4. Section 1.4 deals with complex numbers. This is really the first section where I don't expect you to know any of this. You may know some of it. You may know all of it. Depends on how good your high school math was. Not expecting. Complex. So let's talk about what a complex number is. Complex number is. Complex number is a number of a certain form. A certain way we can write it. It looks as a plus what is all this stuff? So A, B are real numbers. Those are the ordinary numbers you're used to using. To give you a little bit of review, you may be rusty on exactly what real numbers are. So we have whole numbers, 1, 2, 3, 4, 5. Or natural numbers, we have 1, 2, 3, 4, 5. Whole numbers, we have 0, 1, 2, 3, 4, 5, 6. Include rational numbers. When we get fractions involved, half, 2/7. Have irrational numbers. Those are numbers that we cannot write fractions. Those are things like square root of 2, pi. We try to write them in decimal form. They just go on and on forever. And if we take all of those together, and negative numbers, right? We've got negative integers. Take all those together, that set of numbers is what we call the real numbers. Positive and negative whole numbers, fractions, irrational numbers, all those are real numbers. And I here, what we call the imaginary unit. Imaginary unit, we're going to say that I root of -1. Or lots of times we think about it this way, that I squared equals Normally, real numbers, we say square root of a negative number is undefined. Like if we have square root of -4, there's no way we can get that with real numbers because that would mean we have two numbers we'll multiply together and get a negative. It has to be the same number. But if you try out like -2 times -2, you get +4, not -4. We're only thinking about real numbers. Anytime we have the square root of a negative, that would be undefined. So what we're doing with complex numbers, we're saying, okay, instead of saying the square root of a negative is undefined, let's give it a definition. The definition we're giving it is anytime we have square root of -1, we call that I. I is really a radical. Square root of negative. And if we take our a plus bi, put all that together, we get what we call a complex number. Sometimes people just call them imaginary numbers because of the imaginary unit I. Really, it's more precise to say complex. Tiny soapbox, I won't spend long on it. Imaginary is a really bad name for a number. Say we've got an imaginary number or an imaginary unit because it makes it seem like they're, and then we call the other ones real numbers, right? So these are real numbers and these are imaginary. That's really a poor naming convention because there's really nothing more imaginary about I than there is about the other number. All numbers are imaginary. And they're all made up in our head. Now, if I say show me 3 apples, you can show me 3 apples. But if I say show me 3, you can't do it. It's just an idea. You might say, okay, here's 3. No, that's a scribble. Scribble, and we have assigned that the idea of 3. So really, there's nothing more imaginary about imaginary numbers than any of the other numbers you use every day. Don't look down on them. Imaginary numbers come up in real life all the time, and we call them imaginary. Anytime you're plugging something into the wall and using AC electricity, imaginary numbers are all involved all over the place with AC electricity. About they come up all over, so they're really not that imaginary. Right, so small soapbox, I'm done. Let's get a little more information here. So we can write complex numbers as a plus bi. So the a part called the real part of our complex number. B called the imaginary part. And I, we already know what it's called, it's the imaginary unit. So if I ask you what the real part of a plus bi is, A. To ask you what the imaginary part of a plus bi is, B. Not bi, B. So let's look at some complex numbers here. Here's a complex number, 2 plus I. What's the real part of that complex number? 2. This is a little tricky right to start with. What's the imaginary part? 1. Yeah, there's an understood 1 right here. So the real part's 2. Imaginary part's 1. Complex number. Let's do another one. There's another complex number. Well, let's make it negative so we have a minus. Works too. Say that's a complex number because if we wanted to write it strictly by our definition, we would say 3 plus. What's the real part of that one? 3. What's the imaginary part? Negative 5. Negative 5. Throw you one more curveball. Oh, right color here. There's a complex number. Uh-oh. Turns out all real numbers are also complex numbers. What's the real part of 7? 7. Good. All right, here's the tricky part. What's the imaginary part? Nothing there, right? What number's nothing? 0. So if we wanted to write it strictly by the definition, we could say. So every real number we can write as a complex number. Every real number is also a complex. All right, so a couple operations here. So what we're going to end up doing by the time we're finished with 1.4, we won't get all this today. We want to be able to add complex numbers together, subtract complex numbers from each other, multiply complex numbers together. Then we want to be able to divide. Dividing is a little weird. It really looks more like rationalizing. There's one other operation that we don't have with real numbers that we can do with complex numbers, where we simplify different powers of I. That's a preview of where we're headed. So let's get the easy ones at least out of the way today. Talk about adding and subtracting these. So we got 2 complex numbers, so plus I. We're going to add that to another complex number, 2 minus 3. Two complex numbers. I want to add them together. If you've done this before, this is super boring, I'm sorry. We want to add these together. Turns out it's really easy. All we have to do is we add the real parts together. We add the imaginary parts together. And when you do that, really, this works out just like an algebraic expression. You imagine, as bad pun there, if you treat I like an X, you already know how to do these. It's just like combining like terms. So I want to take the 1 and the 2, those together. 3. And then I want to take the I, the negative 3I, Add those together. So I plus negative 3i or I minus 3i, however you want to think about that. Negative plus 2 is 3. 1 minus 3 is negative 2. Okay. We had 1 plus x plus 2 minus 3x. It would have worked out the same way. So like that. Question? Not bad, right? Okay. So addition, nothing much to it. You just add the real parts, add the imaginary parts. What about subtracting? Let's just take our same two numbers. 1 plus I minus 2 minus same two numbers, but this time let's subtract them. And you can treat it just like we did with algebra expressions. We want to take the real parts and subtract them, and the imaginary parts and subtract them. Then the tricky thing here, you just have to be careful with the signs. So one thing we can do is we can take this minus sign and think about it like distributing it. That's exactly what we did with algebraic expressions. We have 1 plus I minus 2. That turns into plus 3i. We can just add. We'll have 1 minus 2, that's negative 1. Real parts. Do the imaginary parts, 1i plus 3i. 4i. So just like combining like terms, I combine this. Hanging in there. Pretty sleepy. Cloudy outside. Not too sleepy. I am somehow not as sleepy as I usually am. I don't know how. Math teacher confessions, after lunch I'm sleepy. Every day pretty much. I'm with you. Adding and subtracting, not much to it. Do multiplying, we'll be done. Well, I'll let you out of here. Multiplying, not too much more complicated. There's only one other thing we have to think about. Most part, we can still treat these just the i's just like variables. We have one other little thing we have to be aware of when we simplifying our answer. So let's think about this. 3i times so those are x's instead of i's. What would you say we need to do to multiply this out? What? Distribute, yeah, the distributive property. So that's what we're going to do. Multiply the 3i by the 2, 3i by the 2i. 3i times 2, we get I. When we do 3i times 2i, 3 times 2 is 6. But I times I is what? I squared. I squared. And the issue here is this is not fully simplified. Because with complex numbers, we don't want to leave I squared in there. Because don't let me make you motion sick, but why? Because I squared We can simplify that. I squared is -1. So anytime we have an I squared, we can replace it with a -1. Simplify things. So this one, make a little note over here. We're using the fact that I squared equals -1. So this will be 6I plus 6 times -1. Six times -1 is -6. And if we want to put it in A plus BI form, some of the problems will say put it in A plus BI form. So we want the real part first and then the imaginary part in the I. So all we have to do is switch the order here so we can say -6 plus, that would be A plus B. Pleasure. And do another one. Here we got two complex numbers we want to multiply. If they were x's instead of i's, what would you say we should do? Multiply that out. Two terms on each one, right? So that's FOIL. We can do the same thing here. FOIL, so 1 times 5 is 5. There are outer terms, 1 times -2i. Inner terms, -3i times 5, that's 15i. The last terms, we've got to be careful here with the signs. -3i times -2i, positive 6. I times I is I squared. Anytime you see that I squared, it should make you uncomfortable. Now you got to change it to a -1. So we combine the terms in the middle, -17. And 6 times -1 is -6. Here, if we combine like terms, we've got a 5 and a -6. Gives a -1. I didn't do too much at one time. I'm trying to pick that up just a little bit now that we're combine these two, and then I squared turns into -1. So combine the 5 with a -6. No questions on that one? Stop there for today. That's enough. You did not get on the sign-in sheet. It's up here at the front. I'll put it on this table over here. Make sure you get on there before you leave. We'll finish this up next week. Don't forget our first assignment's due tonight on WebAssign if you haven't done it yet.